Hello, in this video I'm going to talk through the other type of sequence that you have to be familiar with for GCSE maths. This is the most complicated of the sequences that you need to be able to deal with. Okay, so I'm just going to go through step by step some of the things that you need to know. A quadratic sequence is a sequence with squaring involved. And you'll see the word quadratic coming into the GCSE course whenever we've got squaring. To help you remember, quadratum is Latin for square, so that's why it's called quadratic. Okay, I've written the first few quadratic sequences here for you. If I had n squared, I'm going to get the square numbers. 2n squared is going to be double the square numbers, and 3n squared is going to be triple the square numbers. You'll see what we can do is just take these values and then multiply them to go from one sequence to the other. Let's have a look at some more complicated quadratics, and let's have a look at some of the patterns we see. Okay, these are the first 5 terms of the sequence 2n squared plus 5. Now, with quadratic sequences, you will find that they have something called a second difference, and I'm going to do a couple of examples of that so you can see how it works. To find the second difference, I first of all need to find the differences. So, to go from 7 to 13, I'm adding 6. To go from 13 to 23, I'm adding 10. To go from 23 to 37, I'm adding 14. And to go from 37 to 55, I'm going to be adding 18. So those are the differences. You'll notice they're different every time. However, there is a pattern to them. What I'm now going to do is find the differences of the differences, which we call the second difference. So between 6 and 10, that's a gap of plus 4. From 10 to 14, that's a gap of plus 4. And from 14 to 18, that's a gap of plus 4. This is called the second difference. If the second difference is the same every time, you have yourself a quadratic sequence. Here's another example of getting the second difference. These are the first 5 terms of the sequence 3n squared minus 1. To get from 2 to 11, we need to add 9. From 11 to 26, we add 15. From 26 to 47, we add 21. And from 47 to 74, we add 27. So at this point, the differences are different every time. There is, however, a pattern to them. I'm now going to work out the second difference. From 9 to 15 is plus 6. From 15 to 21 is plus 6. From 21 to 27 is plus 6. So the second difference is 6. Okay, so your turn now. Have a look at these sequences and see if you can find these second differences. And here are the solutions. Okay, so I'm now going to talk you through how to find the formula for the nth term given the sequence. Okay, so for this sequence that we looked at earlier, we found the second difference was 4. If you halve the second difference, you will get the number in front of n squared in the formula. So 4 divided by 2 gets us a 2 for the n squared value. This sequence that we saw earlier, the second difference was 6. If you halve that number 6, you will get the number in front of the n squared, 3n squared. So 6 halved gets us that 3 at the beginning of the formula. I'm now going to use that really important fact to help me get to the formula when I'm only given the sequence. So the first step to finding the formula of a quadratic sequence is finding the second difference. If you're not very confident doing this, just get into the habit of finding the second difference, because you will therefore already pick up the first mark, even if you can't get all the way to the end every time. So looking at the differences, I've got a gap of 3, then I've got a gap of 5, then a gap of 7, and then a gap of 9. Those are the differences. The differences between the differences, I've got 2, I've got 2, and I've got 2. We have to half this number in order to find out how many n squareds I've got. Half of 2 is 1. So I know my sequence is related to 1 n squared. But I then have to think about what I have to do to edit 1 n squared to get to the sequence I want. The sequence of 1 n squared is just the square numbers, okay? So 1, 4, 9, 16, 25, and so on. I'm going to write my sequence underneath, 10, 13, 18, 25. And I now have to look at what I have to do to the square numbers to get down to my sequence. I have to add 9 here, add 9 here, and add 9 here. So every single time I add 9. So it's 1n squared plus 9. That is the formula for this sequence here. Because it's only 1n squared, you don't have to write the 1 in front if you don't want to. You can just write n squared plus 9. Here's another example. Okay, so I'm going to start by finding the second difference. From 9 up to 21 is going to be 12. From 21 up to 41 is going to be 20. From 41 up to 69 is 28. And from 69 up to 135 is 36. Okay, those are my differences. I now need to find the second differences. That's a gap of 8, that's a gap of 8, and that's a gap of 8. To go from the second difference to the number in front of the n squared, I have to halve it. So half of 8 is 4. So I know my sequence has 4 n squared in. I then need to work out the rest of it. So 4n squared is the square numbers multiplied by 4. So the square numbers are 1, 4, 9, 16, and so on. So 4n squared is each of those times by 4. So 4, 16, 36, and 64. I'm now going to write my sequence, and we'll then be able to compare them. From 4 to 9 is add 5, same here, and same here. So this sequence is the 4n squared sequence plus 5. So the formula is going to be 4n squared plus 5. Okay, so here are some questions on finding the formula for the nth term of some quadratic sequences. Have a go, and I'll talk through the answers in a few minutes. Okay, so here are the answers. Do bear in mind that if you get given one of these questions in a GCSE exam, it will be worth 3 marks, so you can spend 3 minutes on it. So you probably didn't get through all of those questions in that time. If you got through 1 or 2 of them, your pacing will be absolutely fine for a GCSE exam. Okay, so here is an AQA GCSE question. The part B is grade 9 and it's a little bit more complicated than the examples I've done with you so far. So have a go, get as far as you can. I'm going to do a full walkthrough once you've had some time to have a think about it. Okay, I'm going to stop there and talk through the process. I doubt many people have got to 7B because that one is a more complicated one. So, having a look at the gaps between the numbers of the sequence we've been given, we've got plus 14, plus 22, and plus 30. If we look at the differences between those numbers, we'll find that every time there's a gap of 8. So the second difference is 8. If we continue that pattern on, we can work out what we have to add to the 75. We're going to need to add 38, and that will get us 113 as the next number in the sequence. Carrying on the red sequence, we need to add 46, and that's going to get us 159. Now, for the nth term, we're going to need to be using the second difference again. We halve the second difference to get 4 n squareds in our formula. It will now help to compare the 4n squared sequence with the one that we've been given. And we're going to look at each time what we have to do to the 4n squared sequence to get to the sequence we want. The reason this is more difficult is that instead of having a constant number that we always add on, instead we've got a linear or arithmetic sequence. So at this point, what you have to do is find the formula for the arithmetic sequence. And it's this added complexity that makes it a grade 9 question instead of a grade 8 one. So it's going up in 2s, and the formula for that arithmetic sequence is 2n plus 3. You have to make sure you're happy on how to find the nth term of an arithmetic sequence. So if you can't do that, you want to look back on how to do that in your revision before you try these. So what we have here is the 4n squared sequence with this sequence added onto it. So the formula for the quadratic sequence we were given is 4n squared plus 2n plus 3.